It says complete the table describing exponential growth or decay. So in this case, since they're getting bigger, we know that it's going to be a growth. So we're looking at something like P of t equals P naught b to the t, where b is our growth factor. And in this case, since they're growing, b that I'm going to find is going to be bigger than 1. So to get to each successive one, I must be multiplying by some number. That's how we know that it's an exponential growth. So I multiply by something, and then I multiply by something, and then I multiply by that same number to get to each next successive term. And in order to find what that growth factor is, remember I can look at the ratio of any two. Ratio of two p-values. So let's say I take 24 and I divide it by the previous one, 16. It looks like that gives me 1.5. And if I take the next two guys, if I say 36 divided by the previous guy, 24, if that's also the same ratio, then this is going to be an exponential growth. And if I do that, it looks like it ends up being 1.5 again. So it means that basically to go from one to the next one, I keep multiplying by 1.5. That's why when I looked at their ratio or their quotient, it ended up being 1.5 for each two successive. Remember we said the next one over where you were at currently, or if I'm currently at 16, the next one would be 24, 24 divided by 16. So the growth factor in this case, b, is 1.5, and each time to get to the next one, I just multiply by 1.5. So I took 36 and I multiplied it by 1.5, it spit out 54. Then I took 54 and I multiplied it by 1.5 and it spit out 81. Complete the table describing exponential growth or decay. And in this case, since these numbers are going lower as I go from one to the next, it must be a decay that I'm dealing with. So if I want to find the decay factor, P naught b to the t, if I want to find this guy, I know that b is going to be less than 1 because this is a decay and the terms keep getting smaller. So how do I find that? Again, I look at the ratio of two p-values, two successive ones, and there are only two I have to worry about here. So I take this 84 and divide it by the guy right before. So it's always two successive ones. This divided by that, or this divided by that, or this divided by that, and so forth. So if I do that, I get 0.8, which means each time to go from one term to the next, I'm multiplying by 0.8. Multiplying by the same number less than 1 to get the decay happening for each one. So take 84 and multiply it by 0.8. And you get 67.2, and do the same thing. Now take 67.2 and multiply it by 0.8 again. We get a smaller number, of course, because it's decaying, 53.76. Now take 53.76 multiplied by 0.8 to get the last one. So again, this was a decay since the values were going down. And how did we find that decay factor? We took this next guy and divided it by the previous one. If I take any of these two guys, if I take 43.008 and divide it by 53.76, I would expect it to be 0.8. Complete the table describing exponential growth or decay. So it looks like the values got lower as I'm going down. T is increasing, but P is decreasing, so we know it's going to be a decay in this case. Now, something is missing. It's a little bit different than the previous examples. So I'll start with the same business. P of t is going to be P naught b to the t. I do know P naught from the table because P naught is always the initial value or what's associated with t equals 0. So let's go plug that guy in. P of t is going to be 10 times b to the t. So initially, when t is 0, notice b to the 0 is gone, and I get left with 10 of whatever these guys are. So I have P of t equals 10 b to the t, In order for me to divide two successive ones, I would need to know what this is to divide it by 10, or take this and divide it by whatever this guy is to find my b. So instead of doing that, since some things are missing, we'll just use this piece of info given that says when t is 2, p of t is 1.98. So we'll use that and plug in the givens to find my unknown in this case. So p of t, this is my t, this is the corresponding p of t. P of t is 1.98. B is the guy I don't know. I'm trying to find the decay factor. And I do know that the t value here is 2. So now I have a quadratic equation with the b being the unknown, so I'll divide both sides by 10. So b squared equals 0.198, and then I'm going to take square root of both sides to find b. So b is going to be approximately plus or minus, but I know I'm not going to worry about the minus. It's just a decay rate, and we're going to take b to be positive. Let's say I have 0.44497, it looks like, and it says 2 decimal places. So b is going to be approximately, I guess, 0.44. I only worry about the positive one. And once I know b, I know what to multiply each successive one to get to the next one. So to be safe, I'm going to carry 5 digits to get each next term, just not to have too much round-off error. So I get 4.4497. If they wanted input in as 2 decimal places, you would put 4.45. Now notice this is a good way to check your work. To get from here to the next term, you would be multiplying by that decay factor of approximately 44497. And if you take this number and multiply it by this, you will see that you get fairly close to 1.98. You get 1.97998. So that's another confirmation that, all right, I have the right b value. So now let's take this guy and multiply it by the b to get the other ones as well. So 1.98 by the b gives me this. I carried some more digits, and then I multiplied that result by the b value of 0.44497 again, and I got 0.39. So that gives me the table. If I needed to know what the model is, I could take this b value and put it in here, and that would give me the overall model, in which case I could just punch in 1, 2, 3, and 4 for my exponent, and it would spit out these values anyway. So in other words, though it didn't ask for the model, this would be the equation. Without any approximation, it's 10 times the base of square root of 0.198 raised to the t. So if you want to get these values, you could also plug in 0, 1, 2, 3, 4 into your calculator, and it'll spit out these p-values. But we know that each time to get there, we're just multiplying by a factor of b.